How many websites have you visited today? How many of them logged your IP address, your browser fingerprint, your location data, your device identifier? You don't know, do you? Because they don't tell you. Your ISP doesn't ask permission to log your entire browsing history. Websites don't announce when they're fingerprinting your browser. And incognito mode? That's just theater. Welcome back to Tech Sky. Today we're diving deep into digital privacy and anonymity. Not for illegal activities, but because privacy is a fundamental human right that everyone deserves to understand and protect. I'll show you how to actually become anonymous online using multiple layers of protection. By the end of this video, you'll understand what true digital privacy looks like and how to implement it properly. Let's be clear about why this matters. Privacy isn't about having something to hide. It's about having something to protect. Journalists need anonymity to protect sources investigating corruption. Whistleblowers need it to expose corporate crimes without retaliation. Activists need it to organize against oppressive regimes without disappearing. But it's not just them. You deserve private conversations, private thoughts, private browsing. The normalization of total surveillance doesn't make surveillance acceptable. Your internet provider logs every website you visit. Advertisers build psychological profiles from your behavior. Governments monitor traffic at scale. And most people think incognito mode protects them, but it doesn't. Real anonymity requires understanding what you're actually protecting against. Now let's understand the 7 layers of digital identity. Each layer reveals who you are through different signals. Layer 1 is network identity. Your IP address, your MAC address, your DNS queries, your traffic patterns. Everything visible at the network level. Layer 2 is device identity. Your browser fingerprint, your operating system, your hardware specifications. The unique configuration that identifies your device even when your IP changes. Layer 3 is behavioral identity. Your typing patterns, your writing style, your browsing schedule. The habits that reveal who you are, even through anonymity tools. Layer 4 is account identity. Your email addresses, your usernames, your passwords. The accounts that link your anonymous activity to your real identity. Layer 5 is payment identity. Your credit cards, your cryptocurrency addresses, your gift card purchases. The financial trails that connect transactions to people. Layer 6 is physical identity. Surveillance cameras, GPS tracking, home Wi-Fi networks. The physical world fingerprints that expose location, even when digital identity is hidden. Layer 7 is social identity. Your contacts, your photo metadata, your relationship patterns. The social graph that reveals identity through association. Today we begin Layer 1, network identity. We'll cover the practical foundation, the tools that protect your network identity, and demonstrate real anonymity in action. So let's get started. First thing we always do is update the system. Open your terminal and run sudo apt update to refresh package lists, then sudo apt upgrade to install available updates. Now we'll install Tor, the most robust anonymity network that exists. Run sudo apt install -y Tor Browser Launcher. This installs both the Tor service and the Tor browser. Start the Tor service with sudo systemctl start Tor. Enable it to start automatically on boot with sudo systemctl enable Tor. Verify it's running with sudo systemctl status Tor. You should see active in green. Now let's test it. First, check your real IP address. Run curl if config.me. This shows your actual IP address that websites see. Now route that same request through Tor. The command is on screen. We're using curl with SOCKS 5, pointing to our local Tor proxy on port 9050, and hitting the Tor project's IP verification API. Notice the IP address is completely different. That's a Tor exit node IP, not your real address. And here's the critical part. Tor uses onion routing. Your traffic passes through 3 relays: an entry guard, a middle relay, and an exit node. The entry guard knows your real IP, but not your destination. The middle relay knows neither. The exit node knows your destination, but not your real IP. No single point in the chain sees both ends. That's why Tor actually provides anonymity, while VPNs just shift trust. But manually routing every application through Tor is tedious. That's where ProxyChains comes in. ProxyChains forces any application to route through Tor automatically. ProxyChains comes pre-installed on Kali Linux. We just need to configure it. Open the configuration file with sudo nano/etc/proxychains4.conf. Find dynamic_chain. If it has a hash symbol, remove it to uncomment it. A few lines below, comment strict_chain by adding a hash in front. Only one chain mode should be active at a time, and the last uncommented one wins. Scroll down to proxy_DNS. Make sure it's uncommented. This forces DNS queries through Tor, preventing leaks to your ISP. Scroll to the bottom. You'll see a line with SOCKS4 and the localhost address. Change SOCKS4 to SOCKS5, because Tor uses SOCKS5. Save with Ctrl+S, exit with Ctrl+X. Now test it. Run ProxyChains for curl if config.me. Watch ProxyChains route the request through Tor automatically. Different IP, different location. Any TCP-based application launched through ProxyChains 4 now routes through Tor. But there's another network identity we need to randomize: your MAC address. Your MAC address is a hardware identifier assigned to your network interface. Every Wi-Fi network you join logs it. Even when you change your IP, your MAC stays the same, making you trackable. Let's randomize it. First, check your current MAC with IP link show. You'll see your network interfaces listed, usually ETH0 for wired or WLAN0 for wireless. In our setup, we'll use ETH0. On a physical machine with Wi-Fi, you'll likely use WLAN0. Check the current MAC address assigned to ETH0 with MACchanger-S ETH0. You'll see the permanent MAC, which is burned into hardware, and the current MAC, which is what's being used. To randomize it, first bring the interface down. Run sudo IP link set, ETH0 down. Now randomize the MAC with sudo MACchanger-R ETH0. The -R flag generates a completely random MAC. Bring the interface back up with sudo IP link set ETH0 up. Verify the change with MACchanger-S ETH0 again. Notice the current MAC is now different from the permanent MAC. Every network you join now sees a random MAC instead of your real hardware identifier. Now let's address browser fingerprinting. Open Firefox and visit amiunique.org. Click the See My Fingerprints button. This site shows your browser fingerprint. The unique identifier created from canvas rendering, WebGL capabilities, installed fonts, screen resolution, and other signals. Look at the fingerprint details. Your canvas fingerprint is unique. Your WebGL renderer is exposed. Your time zone is visible. Combined, they identify you uniquely among millions of users. Now let's compare that to Tor Browser. Launch it by typing Tor Browser-Launcher in the terminal. The first time you run this, it will download Tor Browser automatically. When it opens, click the Connect button. Wait for the connection to establish. Once connected, visit amiunique.org again. Compare the fingerprints side by side. Notice the difference? Canvas is blocked. WebGL is disabled. Time zone is spoofed to UTC. Tor Browser makes your fingerprint identical to millions of other Tor Browser users. You blend into the crowd instead of standing out. Notice something important. Tor Browser is doing more than just routing through Tor. It's also blocking browser fingerprinting. That's a glimpse of Layer 2, device identity. For now, the takeaway is this: using Tor Browser is the right way to use Tor. One more thing. If you want maximum anonymity, Tor Browser isn't enough. You need Tails, the amnesic incognito live system. Visit tails.net to learn more. It's an entire operating system that runs from a USB drive, routes everything through Tor by default, and leaves no trace on the computer it runs on. When you shut down, everything disappears. No logs, no history, no artifacts. For most people, Tor browser is sufficient. For journalists in hostile countries, Tails is essential. Finally, let's automate some of this with Tornet, a command line tool that simplifies Tor operations. Install it with pipx install Tornet. Check available commands with tornet-help. You'll see options for IP checks, circuit rotation, DNS leak tests, and more. Check your current Tor IP with tornet-IP. It queries through Tor and shows the exit node IP. You can force circuit rotation with Tornet, --interval 30, --count 3. This rotates your Tor circuit every 30 seconds, 3 times. Tor builds new circuits periodically. The same circuit might be reused for several minutes before rotating. Run a DNS leak test with Tornet, DNS-leak-test. This verifies your DNS queries are actually going through Tor and not leaking to your ISP. When you're done, stop Tor with Tornet-stop. Here's the truth privacy advocates don't like admitting. These tools reduce tracking. They don't eliminate it. In 2013, a Harvard student sent a bomb threat through Tor to avoid an exam. Tor worked perfectly. He got caught because he was the only person on Harvard's network using Tor at that exact time. Network admins saw one Tor connection and one bomb threat email. Correlation was trivial. Tools protect maybe 10% of your anonymity. Your behavior protects the other 90%. The tools work as designed. Humans don't. What we covered today is the practical foundation of Layer 1, network identity. The tools that work. The demonstrations that prove they work. But Layer 1 has depth that didn't fit in this video. Tomorrow, the Layer 1 mastery continues, exclusively for channel members. Bridges that bypass Tor censorship in countries where governments block Tor. Hosting your own anonymous onion service that exists only on the dark web. Country-specific exit node selection. Multi-method DNS leak verification, because trusting one test isn't enough. The cryptographic internals that explain why onion routing actually works. And the brutal truth about what Tor cannot protect against. This is part of the complete 7-layer anonymity series. Network, device, behavior, accounts, payments, physical, social. Each layer gets the same treatment. Click the info card appearing above and join Master Tier. Until then, this is Tech Sky, your ultimate battleground of cybersecurity and ethical hacking. Stay curious, stay ethical, and keep learning.
Make it run, 抱紧的包包里，好长的奶子，弯进的爱，锁进了我的。